get started. Thanks everyone and welcome to today's webinar, Phius 101, Foundations of Passive Building and Phius Standards. My name is Miranda Wright. I'm Education and Engagement Manager at Illinois Green Alliance, and I'm excited to be hosting this webinar and series in partnership with Phius. Today is just the first in the series, Road to PhiusCon, as we provide education and networking opportunities throughout the year, prepping for PhiusCon in Milwaukee in October. We have a lot packed into today, so likely we'll not have time for Q&A, but in May, we will be hosting a question and answer forum with the Phius folks. So if you are sitting there having more questions, there'll be opportunities here soon that I'll be sending out to the whole community, as well as a follow-up email for people to register for that. For those unfamiliar with Illinois Green, we are a membership-driven nonprofit organization advancing green buildings and sustainable communities for all. Our 5-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through education events such as today, by engaging communities and partnering with organizations like Phius, and by advocating for new policy and legislations. Members can view this recorded webinar and others on our on-demand library, and you can view more on our website. Also want to take a moment to recognize our Illinois Green Alliance sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, USGBC, and Sloan. And then now I would like to pass it over to our two speakers joining us today from Phius, Isaac Elmcave and Zoe Rader. Isaac, the floor is yours to introduce yourself and Illinois policy and codes promoting Phius.
On mute.
Let's try it again. Good afternoon. My name is Isaac Elmcave. I am the Senior Policy Analyst at Phius. My work is mostly devoted to promoting and implementing and pushing for policies across the country to promote and develop Phius projects or projects that meet the Phius standard. Today, since this is an Illinois Green Alliance event, among others, we'll talk about a little bit about Illinois policy and set the stage for why we think that it's important to do to get more up on the Phius standard. Illinois has done a lot of work in developing policies at Phius that promote Phius. Two of them are related to the low-income housing tax credit, both at the Illinois level, at the state of Illinois level, through the Illinois Housing Development Authority, where you can get anywhere from 10 to 13 points on when you choose to certify with Phius, and then even in Chicago as well, we are incorporated into the Chicago Sustainable Development Policy, where you can get 90 points if you certified to Phius, and 95 points to be certified to Phius 0. So you have some fairly strong incentives to do so on the low income side. Next slide, please. And just as importantly, Phius is incorporated into Illinois energy codes. In Illinois, there are 3 levels of energy code. Number 1, there is the state of Illinois, kind of the base code, the statewide code, typically based off of the IECC, and in this case will be the IECC 2024. And in that base code, we have added an alternative compliance path, which basically means that if you certify to Phius, you are deemed to be compliant with the code, and you don't have to go through all of the compliance features that are involved in the International Energy Conservation Code. The state of Illinois also has a stretch code, and we are also there. Phius is also included there, and importantly, the first city in the state has adopted the state of Illinois stretch code. Evanston did so, I believe, last month. So that's there. And then Phius is also included in the Chicago Transformation Energy Code. And again, one of the big advantages here, and building officials have told me multiple times, by going through Phius and doing the certification, they feel comfortable that they're getting a good energy efficient building. And that way they don't have to, they can focus on other aspects of the code. So now that we have established the baseline of why we think that there's going to be we have a lot of opportunity to move forward on the development, the design and construction of Phius projects, I will turn it over to Zoe Rader to talk about what exactly is Phius.
Thank you, Isaac. All right. As Isaac said, I am Zoe Rader. I work with Phius as a building certification associate and a policy specialist. So I get to certify projects on a day-to-day basis, and then I get to help Isaac on the policy side of things, helping to get Phius more incentivized and hopefully required by code in certain places as well. So today we're going to go over a Phius 101. So just an introduction to passive building and Phius certification. So we're going to go over what is Phius, what is passive building, how is passive building the first step towards net zero energy consumption, how to certify a passive building through Phius, and key players and tools involved with Phius certification. So what is Phius? Above all, Phius seeks to drastically reduce the contribution of building energy consumption through passive building. So Phius certifies buildings, we certify people, we certify products. So when it comes to people, we have Phius certified consultants, often referred to as CPHCs. And then we also have Phius certified raters and verifiers. And then when we're talking products, we have a really cool window certification program that lays out all of the window data needed for energy model inputs. Phius works with existing peer institutions such as the U.S. Department of Energy. So we work with Zero Energy Ready Homes, the WaterSense program, Indoor Air Plus, Energy Star, etc. We'll go into a little bit more depth further on in the presentation about those. And most importantly, Phius fosters and is supported by a community of education and collaboration, which is the Phius Alliance. There is a Chicago-based Phius Alliance. There is a Wisconsin-based Phius Alliance. If you are looking for an alliance chapter, you can always reach out to Phius and see if there's one near you. So a lot of times we hear passive house and immediately think that you can only certify houses, single family homes. So contrary to that thought, Phius also certifies many building types, single family, residential, very common, but up and coming, growing exponentially. We also certify multifamily buildings. We certify non-residential commercial buildings, and then we do new construction and retrofits as well. So Phius provides a climate-specific standard, which customizes approaches for the wide range of climates in the US and beyond. So some of the passive building standards, history and evolution. So the passive building methodology was first developed on a theoretical level in the US at the University of Illinois. A lot of people think that it was originated in Germany, but theoretically it was honed in Urbana, Illinois. The first passive buildings were constructed in North America, and then the idea then moved to Europe. PHI, which is also Passive House Institute, formalized the method into the first certification system in 1996. And then in 2015, Phius created the climate-specific certification standard, which is applicable to a wider range of climate zones throughout the US and beyond. So what is passive building? Passive buildings have flattened loads on a peak and annual basis. So these charts here represent the annual energy consumption of two buildings, one conventional, one passive. So it's important to note that lighting, appliances, domestic hot water use is consistent throughout the year, and then heating and cooling varies based on the building's climate. The total energy consumption is the area under the red and the blue curves combined. And then the total peak power consumption is the bold black dot at the peak of the curves, which is the most amount of energy spent at a given moment during the year. The y-axis is showing the amount of energy consumed in kilowatts, and then the x-axis here shows the duration of a single year. So this chart is showing a heating dominant climate specifically, but it's important to note that the same concepts apply for cooling dominant climates as well. And you can notice on the passive building chart there that it's overlaid on top of the typical building chart. And so you can see that direct savings for the heating and cooling consumption. So what does passive building deliver? Passive building helps to deliver safety, healthy interior, a comfortable interior environment, long-term affordability, durability, and resilience. So the next few slides are an overview of the critical elements of the passive building method. So the top half of the circle, highlighted in orange, outlines the primary passive building principles that will be covered in the next few slides. And then the bottom half of the circle, those outlined in blue and green, will outline more advanced tools and concepts that are considered in this process. So passive building principles, we have them broken down into thermal control, air control, and radiation control. So with thermal control, we have high performance insulation, high performance enclosure. So we're looking for an over insulated envelope. Especially in the Midwest, it's really common to see 2x6 stud framing with cavity insulation and then exterior continuous insulation on the outside of that as well. And then we are looking at thermal bridge elimination. And so where is that insulation interrupted? How can we mitigate that? When it comes to air control, we're looking for airtightness. Airtight construction creates a controlled environment that supports balanced ventilation and heat recovery. These go very hand in hand here. And then the enthalpy recovery ventilation, also known as energy recovery ventilation. So because we have this super airtight building, we want to make sure that we're getting all the good air out or in, and then getting all the bad air out. And finally, we have radiation control. And so we're looking at window placement, and then glazing, solar heat gain, and shading strategies and solar control. So as a result of all of these, the heating, cooling, mechanical equipment can be minimized both in sizing and in distribution. So first we have continuous insulation. Building codes dictate our minimum R values, insulation levels for buildings, and passive building uses energy modeling to determine the right amount of insulation to meet conservation goals. So this infrared image on the right shows row houses where only one unit has been retrofit to the Phius standard. So where it's dark and red, that's where you can see a lot of heat fluctuation, whereas this center one is the Phius one. It's over insulated, and so there's not as much heat transfer there. So the red, yellow, and orange, these are representing rapid heat loss. And then blue and purple is little heat loss. So the resulting Phius certified envelope demonstrates a continuity of the thermal resistance. And then we have the thermal envelope. So these two images show the importance of high performance windows in maintaining a continuous thermal envelope. The left image showing inconsistency, critical heat loss at existing windows. So where it's red, that's where you're seeing a lot of that heat loss. And then thermal bridges at the roof overhang, the window headers. Whereas on the right image, it's a lot more reduced. You don't see nearly as much red, hardly any at all. And it's a lot more consistent. It's an even heat loss, and there's no thermal bridges here. So windows and doors are always what we like to call the worst offenders in our building envelope. Even some of the best windows at R7 or R11 are significantly less insulated than a conventional code-built wall, depending on locality. And then it's also just kind of important to note that you can see the difference between the left and right here that the existing chimneys were removed because combustion equipment was removed. And so that kind of helped with a couple of those thermal bridges there. So now we have controlled ventilation versus random ventilation. So conventional non-airtight buildings exhibit random ventilation, whereas passive buildings exhibit controlled ventilation. In controlled ventilation, an airtight building envelope ensures that the air exchanging between inside and outside is only from intended locations. So where do you want this ventilation coming from? Where do you want it going to? Whereas in random ventilation, it's impossible to predict the air infiltration. Air is going to come in through leaky parts where floor meets the wall or where your windows aren't installed properly, et cetera, et cetera. And then that's also where your good air is going to get out as well. So controlled ventilation increases the need to bring in fresh air mechanically from the outside. So heat recovery ventilation is essential for passive buildings. This reclaims heat from the exhaust air on its way out and uses the heat to pre-treat incoming fresh air. Energy recovery ventilation regulates humidity in addition to heat. HRVs do not. So more often than not, in the Midwest, you're almost always going to have an ERV. We're a pretty humid area, and so we need that ventilator to be able to recover humidity as well as the heat. But by using an ERV or HRV, less energy is needed to heat or cool the interior spaces. Airtight construction. So the building envelope should be airtight continuously around the building, including the building slab. Phius certification airtightness limit is 0.06 CFM per square foot. And it's 5 times lower than what is required by the building code. Airtightness provides durability in assemblies, and it also supports balanced ventilation, and it reduces the heat loss through infiltration. So having this airtightness means that your building's just not going to be quite as leaky, which in turn, your HVAC systems aren't going to have to work as hard because it only has to heat and cool the actual interior air. You don't have to worry about heating the outside. Oops, sorry about that. And then the device in this image is called a blower door test, and this can pressurize or depressurize a building. The resistance to the pressurization measures the amount of air leakage through the walls, through the roof, through the floor. It's one of these tests that is how we determine if that 0.06 minimum requirement is met. Now we have optimized windows, and this is referring to the correct balance between heat loss through the window and heat gain through sun exposure. So this is specific to your climate, specific to your building type, and it's specific to the orientation. So windows are accounting for the largest amount of heat loss per square foot in a building. Now, it is possible to achieve Phius certification with both double and triple pane glass, though historically triple pane is used much more often. And the thermal analysis diagram here on the bottom left shows various mullion profiles and shows the efficiency of a thermally broken frame. Again, red equals warm, yellow equals cool. So we're looking for one that's more in that yellow area there. Heating and cooling systems are minimized as a result of the drastically lower peak heating and peak cooling loads, which again, achieved through passive means. And Phius promotes electric systems only for maximum energy efficiency and indoor air quality. It's important to note that heat pump heating and cooling systems are anywhere from 2 to 8 times more energy efficient than the top performing combustion furnace and boiler. So now, the previous slides, we were looking at the 5 foundational principles of passive building. In the next few, we're going to focus on the way Phius optimizes these characteristics to provide cost-optimized, climate-specific roadmap to certification. So the Phius standard, it's a climate-specific passive building standard that prioritizes passive building principles and guides builders to success in the design and construction of high-performance buildings. It provides a quality and conservation first framework for net zero building. There are four main certification requirements: space conditioning targets, which are climate specific, air tightness, which is the same no matter what, and then on-site quality assurance, and the final one, source energy target. So the space conditioning targets, annual and peak demands, are variable based on your climate, based on your building size, based on occupant density, and the dwelling unit size. And then financial investment, upfront cost versus operational cost. The net zero energy target varies based on the program level. Are you going for Phius Core? Or are you going for Phius Zero? If you're going for Phius Zero, then source energy has to meet zero. So space conditioning targets were set using cost optimizing and pinpointing the sweet spot for investment and conservation. More and more insulation can be added to the building, but there will always be a point of diminishing returns when looking at upfront cost versus operational cost, i.e. electricity use. So the sweet spot is the maximum amount of investment in conservation before the point of diminishing returns is hit. So the next conservation measure may save energy, but it will increase the total cost. The total cost is the cost of upfront savings measures plus the cost to operate the building, annualized for the life of the building. Ideally, you want to minimize this. Phius has over 1,000 individual climate sets with unique design conditions across the continental US and beyond. The cost optimization exercise is then applied to various climate zones and various building types and sizes to determine the Phius design targets. So you could plan for a single family home on the same exact site at the same exact address as a multifamily, and those targets are going to come out differently just because of the size of the building. Or you could have the same exact single family home that you want to put one in Texas and you want to put one in Montana. Those are going to have different targets based on different climates. Phius now has active projects in Canada, Japan, and Thailand. And if there's not an existing climate set that's appropriate for your building, Phius can and often does create custom climate sets for these sites. In addition to the climate-specific space conditioning targets, Phius certification ensures the highest quality building envelope. So Phius quality assurance and quality control is based on existing US certification systems and third-party inspection of a Phius Rader. And so this is where our partner programs come in, where we look for Zero Energy Ready Home certificates. We look for Indoor Air Plus certificates, Energy Star, and HERS ratings. We have the US Department of Energy high performance staircase. And so it backs all the way down to IECC 2006. And as you work your way up, once you're at the top level, everything below is already combined. So if you are just looking at the DOE ZERH version 2 step, everything below that is encompassed within it. So by the time you reach Phius Zero, you have also reached Phius Core, ZERH, Indoor Air Plus, Energy Star, all the way down to IECC 2006. Passive building focuses on passive measures and is the essential first step towards net zero buildings. The following slides present the concept of net zero energy and relate that concept to Phius certification. So site energy includes only the energy consumed on site. That is lighting, heating, cooling, ventilation, hot water, plug loads, appliances, et cetera, whereas source energy includes the site energy, but it also includes the energy that it took to produce and deliver the electricity from point A to your building. So Phius focuses on source energy instead of site energy so that we can encompass all of the energy it took to get to this final product. as mentioned, Phius focuses on source energy, not just site energy. But the final certification requirement is a net source energy target. The net is net of renewable energy production, all of which is offset for 0, but only some of which is counted for in Phius core. So source energy targets are set differently based on residential or non-residential project. Residential is based on a per person limit, which varies based on the Phius certification selected, Phius core or Phius 0. And then commercial and non-residential is a per square foot limit. And this differs just because we can look at how often somebody is in their house, and we can make assumptions based on that, whereas it varies for commercial and non-residential projects, depending on what type of non-residential project it is. And so with that one, we go by a per square foot limit. Phius stresses a conservation first approach to net zero. This is important when considering the impact of building beyond the building site boundary into the electric grid. So step 1, conservation, first through passive measures, then through active measures. So that kind of goes back to, we're looking at what does your building enclosure look like? And then how can you offset your uses for your mechanical equipment? And then renewable energy, on-site or off-site renewable energy to offset the remaining energy use. But also note that on-site renewable energy is the most common with Phius. So Phius core is based on a per person net source energy reduction based on a global fair share principle. Phius core focuses on the foundation passive building principles, but only requires renewables if the fair share source energy target is not met. Phius 0 is based on a net zero energy consumption per person. Total renewable energy production equals or exceeds the total energy consumption. And then Phius 0 always requires renewable energy and is compatible with all renewable energy sources on or off site. The Phius certification framework is intentionally structured to prioritize first, quality, health, durability, and safety are met with airtightness and a robust third-party quality assurance program. Then turn to passive conservation strategies and meet the space conditioning, demand, and load targets. Okay. Then focus on active conservation strategies, more efficient equipment to meet the Phius core target. And after the conservation strategies are applied, then turn to renewable energy to offset the energy use. A new alternate approach for Phius core. In 2021, Phius released a new prescriptive path to streamline adoption of passive building. The scope is limited to all electric single family homes. So similar to the performance path, the core framework aims at the following priorities. Quality, health, durability, and safety are targeted with the same requirements as the performance path. So airtightness and a robust third-party quality assurance program. Passive conservation strategies are targeted with individual measures per component, like a prescribed wall R value or window U value. Active conservation strategies are targeted with individual efficiency requirements on appliances and equipment. And then renewable energy is not credited in the prescriptive path, though it can be used. This path uses a different approach to achieve the same goal, a conservation first approach to net zero. So the prescriptive path requirements are split into the following 10 categories. 1, the gray is a general scope. 2 through 7, navy blue or passive conservation strategies, and then 8 and 9 in teal are active conservation strategies. So the requirements themselves fall into 3 groups: universal, building specific, and climate specific. The snapshot tool is used to display the Phius prescriptive path requirements that are climate specific. All other requirements are outlined in the prescriptive checklist. And this is a free tool that can be found on our website, just at phius.org. And this snapshot produces recommended R values, window values, and then minimum mechanical efficiencies based on the location, size, and occupancy of your project. So while this snapshot was developed for the Phius 2021 core prescriptive path, it's also a really good starting point for anyone looking to do a Phius project. The difference with prescriptive versus performance is when it comes to prescriptive, these minimums that are laid out, you have to meet those minimums for the wall, the floor, the roof, windows, mechanical equipment, etc. Whereas in performance, these minimums are likely going to be overperforming. And so maybe you can pull back. You don't have to have quite as much insulation in your roof, or you can have better mechanical equipment that allows you to use a little bit less insulation, or vice versa. So just know that with prescriptive, the minimums just have to be met. So the next slides will identify the key project certification players and tools. So when starting a Phius certified project, it's important to identify the critical team members and plan their involvement as early as possible. So the Phius certified consultants are trained professionals that can help design, they can help energy model, and then they submit the project for design certification. Phius certified builders are an invaluable part of the project execution and are trained in passive building construction management means, methods, and details. And then we have the Phius certified rater or Phius certified verifier. So the Phius certified raters and verifiers provide the essential on-site verification and administration required to see a project through final certification. So raters are required for all residential projects up to 5 stories in height. And then Phius certified verifiers, it's an additional designation for Phius raters that's required for large buildings, multifamily buildings included. And there is a separate designation for a multifamily verifier. Each of the team members should be familiar with the critical certification guidelines. So guidelines include moisture control for walls, roofs, and floors, comfort assessments for windows, design requirements for ventilation and heating and cooling systems, etc. These guidelines provide another level of quality assurance to provide the highest quality building that we can possibly achieve. WFI energy modeling software is an essential part of design certification. WFI provides whole building energy simulation to determine the building's specific annual heating and cooling demand, and it verifies those against the Phius targets as well. In addition to WFI and the certification guidelines, there's additional tools available to analyze and design more difficult conditions. So what you're seeing here on the left is our thermal bridging calculator. And so when you are creating a detail, we use Therm at Phius. And so you'll create a detail in this separate program and you plug in your outputs into this calculator, and then it tells you how large of a thermal bridge it is. And then you put that input into WFI. And in addition to the basic certification functions, WFI has advanced features that analyze heat and moisture in building assemblies and the likelihood of mold growth, wood rot, corrosion, etc. And so there on the right, you can see that it's a WFI Pro hygrothermal analysis. And so that will be input into WFI similarly as Therm. The next slides will provide a complete overview of the certification process. So Phius certification is divided into two different stages: design certification and final certification. Design certification ideally occurs before the building has been constructed and verifies that all performance and prescriptive targets are satisfied. And then final certification occurs during construction, and the Phius rater or verifier will verify that the project was built as designed. So this goes back to the QA/QC process that we have, where we want to make sure that the really energy efficient building that was designed is the same energy efficient building that was built. So phase 0, we have a feasibility study. So this is recommended for projects before committing to the certification contract. This is essentially where you have the very basics of a design. You want to know how feasible is my project for Phius certification. So you can go on our website and submit for a feasibility study, and Phius will create an energy model based on usually very schematic drawings provided by the project team. And then we create a Phius version of that project. So 9 times out of 10, that original schematic design is not meeting the targets. And so we give our input based on assembly types, installation types, mechanical systems, etc., and how to best make that project meet targets. And so these can be completed by Phius specifically, or you can do, if you have access to a Phius certified consultant, sometimes they will do a feasibility study as well. Phase 1, we have paperwork. We love paperwork. When the project team determines certification is feasible, the team should register the project with Phius. And so this includes signing a certification contract, creating an entry in the project database, and then paying a certification fee. And it's important to note that fees vary by size and by occupancy. So a single family home is going to be cheaper than a multifamily apartment complex, going to be cheaper than a really large commercial building. So once the project has been created in the project database and receives a project number, the design team can then proceed with the design certification process. So ideally, it's much better if design certification is achieved before construction begins. So during the construction process, a Phius rater will visit periodically to verify the building has been constructed as designed and previously approved by Phius. Final certification can be awarded after construction is complete, and then all documentation has been verified by the Phius certification team. Phius certification is growing rapidly throughout the US and beyond. As of January 2023, Phius certified 3.4 million square feet of building floor area. And as of March 2022, Phius has now over 350 projects enrolled in North America. And now we have some resources and training. The biggest one here is the Phius certification guidebook. We have it set out into 3 overarching sections. Section 0 is about building certification. Section 1, new construction performance path. Section 2, very similar, but it's the prescriptive path. So instead of talking about WUFI and energy modeling, we're talking about that prescriptive checklist. And then section 3 is retrofit, Revive 2024 standard. And then we have our list of appendices here, where a lot of really specific information can be found. I would say the biggest and most visited is probably Appendix B, and that's where we lay out our prescriptive set for opaque assemblies and the moisture control guidelines. And so we have that set out for walls, roofs, floors, because we don't want our buildings to mold. And next we have our Phius resource library. This is an awesome tool found on our website where you can go and search for building components, building science, different types of mechanical systems. You can filter it down by resource type. Are you looking for a calculator? Are you looking for a webinar? Are you looking for a modeling protocol? So if you are newer to Phius, and even if you've been doing this for a while, I highly, highly, highly recommend the Phius Resource Library. And then we have our certified projects database. So just a couple of fun statistics here. In 2024, we had 4.4 million square feet of projects design certified. We had 1.6 million square feet of projects final certified. So they made it through construction. The Rader uploaded all of the documentation, and then the Phius certification team verified and okayed all that and issued final certification. So that totaled out to be 133 projects design certified and 78 final certified in 2024. And we have over 500 total projects certified as of December 2024. Similar to the resource library, the certified project database can be filtered down by various filters such as type, function, location, climate zone, etc. A little bit more about the feasibility study. It's a quick preliminary energy model of your building used to assess the current design and just to determine how feasible is it for my project to achieve Phius certification. Once you submit for this, it takes anywhere between 5 and 10 business days to get it. And then we have this chart here that shows how the fee is determined. You can also find this in the Phius 2024 guidebook as well. A recap of our training: we have Phius certified consultants, builders, raters, and verifiers. The consultant and the builder there's no real prerequisites there. You can take these trainings as you see fit. But to become a Phius certified rater or verifier, you must be an active ResNet HERS rater. And then you also need this HERS rater designation to earn the multifamily designation to become a Phius certified verifier. We also offer WFI passive software training. So this can be for beginners. You can get a little bit more advanced and focus on a single family focus, or you can do advanced with the multifamily focus. Even if you've used WFI before, I find myself referring back to these trainings all the time. You're always going to learn something new. I don't know that anyone will ever know all of the ins and outs of WFI. It's something that we can constantly learn a little bit more about. So I highly encourage the WFI passive software training. And then we have the Phius Alliance. I mentioned this at the beginning. There's likely an Alliance chapter near you. You can become an Alliance member. Some of these benefits include discounted rates on exclusive webinars, our annual conference, the monthly office hours that we host, and the climate data library. So we actually ended a little bit earlier than anticipated. So if there are any questions, I am going to open the chat to see if there's any questions that I can answer now. One quick question: is the guidebook free? Yes, it is free. I would recommend bookmarking it. Don't download it because we do often make updates to it. Jenny mentioned discounts on training as well. What is the cost to go through certification? The cost is going to vary depending on your building type and your building size. So that one, you can find out more information on that in the Phius 2024 guidebook. We have tables and charts. I will tell you, when searching the guidebook, Control F will be your best friend. If you just search fees, it'll be one of the probably 7 options that pop up. Okay, what else do we have? Sorry, I'm trying to make the chat window a little bit larger.
So there's also a question in the Q&A.
Thank you. Appreciate that. Okay. From Chris Murphy, is a HERS rating provided as part of the final certification process? You have to go through the HERS rating process before you can become a Phius certified rater or verifier. So it's not provided as the final certification process, but it's required. And then, yes, we do require continued learning credits. But those can be picked up at our annual conference. Those can be picked up at the trainings that we offer and the webinars that we offer. It looks like Jenny was really good at answering a lot of these questions.
All right, well, if we don't have any questions left, I'm happy to plug some of the next things that are coming down the road for the Road to PhiusCon. So I put in the chat, next week, there's actually an in-person and virtual marketing of passive building that the Phius Alliance Chicago chapter is putting on. So I highly recommend registering for that. There's still some spots for in-person if you're interested. And then you can also meet some of the Phius Alliance group as well. And then as we talked about at the beginning, in May, there'll be a question and answer forum where you can start talking to other CPHCs and their personal experiences with Phius and certifications and things like that. So excited to send that out once those registrations go live. And throughout this year of the Road to PhiusCon, we will be sending out when the next event in the series goes live to all of you. So thank you all so much for attending this first one. And we're really excited to continue this throughout the year. Thank you all. Bye.